Now, in this lecture, we will find out the values of line segments X and Y. In the drawing, we have square BDEF and in the drawing we have square DEBF, and one side of square DBEF equals to 1 unit. The square is inside the right triangle, triangle ABC, and we also know that side AC, that is the hypotenuse of the right triangle ABC, equals to 3 units. And we want to find out the value of line segment FC that equals to X and the value of line segment AD that equals to Y. So first of all, we know that the opposite sides of a square are parallel to each other. That is to say, DE is parallel to BF. I repeat again, the opposite sides of a square are parallel to each other. That is to say, DE is parallel to BF. And we also know that BC is one side of the right triangle, triangle ABC. Therefore, BC is a straight line. I will repeat again. BC is a straight line, and part of the straight line BC, that is actually BE, is parallel to DE. And because of the fact that part of BC is parallel to DE, then BC itself, the straight line BC itself, will be also parallel to DE. So we conclude that BC is also parallel to DE because of the fact that if part of a straight line is parallel to another straight line, then the straight line itself will be also parallel to that straight line. Okay? And we have rule number 1. According to rule number 1, corresponding angles between parallel lines are equal to each other. I write it down. Corresponding angles between parallel lines are equal to each other. So I will read rule number 1 again. According to rule number 1, corresponding angles between parallel lines are equal to each other. So actually those two angles are defined as corresponding angles, and they are located between the parallel lines DE and BC, therefore they are equal to each other according to rule number 1. So actually angle AED, this angle, is equal to angle ECF according to rule number 1. I'll repeat again. Angle AED is equal to angle ECF according to rule number 1. So if we define angle AED as theta, so here angle AED equals to theta according to our definition. From this equation, theta equals to ADE equals to ECF, we will derive that angle ECF also equals to theta. Angle ECF also equals to theta. This angle ECF equals to theta also. So those two angles, they are equal to each other, they are both equal to theta. In the next step I will present to you a new rule number 2. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. I repeat on rule number 2 again. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. AB is one side of the right triangle, triangle ABC, therefore it is absolutely a straight line. AB is one side of a triangle, it is a straight line. I will repeat again. We know that AB is a straight line. So if we focus on this side of the straight line AB, it's point D, then the sum of the angles, you have here angle ADE that we will define as angle X, plus this angle that equals to 90 degrees. In total, the sum of those two angles must be equal to 180 degrees according to rule number 2. So angle X plus 90 degrees must be equal to 180 degrees according to rule number 2. Here we subtract 90 degrees from this equation, and we get that angle x equals to 180 degrees minus 90 degrees, that is to say it equals to 90 degrees. So angle x is a right angle, so I will substitute angle x by right angle. Likewise, BC is one side of the right triangle, triangle ABC, therefore it is absolutely a straight line. So BC is a straight line also. I'll write it down. BC is a straight line. So if we focus on the upper side of the straight line BC at point F, and we will define angle EFC as angle Y, then at point F, on the upper side of the straight line BC, the sum of the angles must be equal to 180 degrees. That is to say, this angle that equals to 90 degrees plus this angle that is angle Y. In total, the sum of those two angles must be equal to 180 degrees according to rule number 2. So I write it down. 90 degrees plus the size of angle Y must be equal to 180 degrees according to rule number 2. So here we subtract 90 degrees from this equation, and we get that angle Y equals to 180 degrees minus 90 degrees. That is to say, angle Y equals to 90 degrees. So we found out that angle Y equals to 90 degrees. So we will substitute angle Y by right angle. And in the next step, we will focus on the right triangle, triangle AED. On the right triangle, triangle AED, we know that tangents theta, here tangents theta equals to AD over DE. I will repeat again, in the right triangle, triangle AED, tangents theta equals to AD over DE. But AD equals to Y according to what is given us in the question, and DE equals to 1 unit because of the fact that all the sides of a square are equal to each other. So DE equals to 1 unit and EF also equals to 1 unit. So DE equals to 1 unit. So in conclusion, we found out that in triangle AED, according to equation number 1, tangents theta equals to Y. In the next step, we will focus on the right triangle, triangle EFC. On the right triangle, triangle EFC, we know that tangents theta equals to EF over FC. repeat again. In the right triangle, triangle EFC, tangent theta equals to EF over FC. But EF equals to 1 unit and FC equals to X according to what is given us in the question. So in the right triangle, triangle EFC, according to equation number 2, tangent theta equals to 1 over X. So we have two different expressions for tangent theta. So we can write down that tangent theta according to equation number 1 must be equal to tangent theta according to equation number 2. This will be equation number 3. Equation number 3 states that tangent theta according to equation number 1 that equals to y must be equal to tangent theta according to equation number 2 that equals to 1 over x. So in conclusion, we found out that according to equation number 3, y equals to 1 over x. Here we will multiply equation number 3 by x and we will get that according to equation number 3, x times y equals to 1. And whenever the multiplication of two numbers gives us 1, it means that 1 is the inverse number of the other. That is to say, we can write down that x is the inverse number of y, and it is also true that y is the inverse number of x. Okay. And we have also a rule that every number has only one inverse number. I'll write it down. Every number has only one inverse number. For example, the inverse number of 5 is 1 over 5 and only 1 over 5, and the inverse number of 1 over 5 is 5 and only 5. Okay, so in the next step, we will focus on the right triangle, triangle ABC. On the right triangle, triangle ABC, according to the Pythagoras theorem, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right triangle, triangle ABC is AC, so the square of the hypotenuse is AC squared, and it equals to the sum of the squares of the perpendiculars, that is to say it equals to AB squared plus BC squared. repeat again. In the right triangle, triangle ABC, according to the Pythagoras theorem, P, the letters P and T is the abbreviation for Pythagoras theorem. According to the Pythagoras theorem, the square of the operator equals to the sum of the squares of the perpendiculars, that is to say, AC square equals to AB square plus BC square. AC equals to 3 units according to Modus Gimenez equation. So AC square will be equal to 3 square. 3 square is 9. And it equals to AB square. AB equals to y plus 1. So AB square will be equal to y plus 1 square plus BC square. BC equals to x plus 1, so BC square will be equal to x plus 1 square. So according to equation number 1, we found out that 9 equals to y plus 1 square plus x plus 1 square. Here we will open the brackets on this side of equation number 4, and we will get that according to equation number 4, y plus 1 square is y square plus 2y plus 1 plus x plus 1 square is x square plus 2x plus 1, and it equals to 9. But according to equation number 3, y equals to 1 over x. Therefore, we can substitute y in equation number 4 by 1 over x. We will do it now, and we will get that according to equation number 4, y squared is 1 over x squared, that is to say it equals to 1 over x squared plus 2y. 2y is 2 times 1 over x plus 1 plus x squared plus 2x plus 1, and it equals to 9. So we will organize the expressions in equation number 4 in a different way, and we will get that x squared plus 1 over x squared plus 1 plus 1 is 2, so plus 2 plus 2x plus 2 times 1 over x equals to 9. So here the expression inside the brackets x squared plus 1 over x squared plus 1 over x squared plus 2 is equal to x plus 1 over x squared and here we'll take 2 as a common factor out of these two expressions, and inside the brackets we will have here x plus 1 over x, and it equals to 9. Here we will define t as x plus 1 over x, That is to say, t equals to x plus 1 over x according to our definition. So we can substitute t in x plus 1 over x, or we substitute x plus 1 over x by t, and we get that according to equation number 4, x plus 1 over x square will be equal to t square plus 2 times x plus 1 over x is 2t, and we will subtract 9 from this equation, so it will be minus 9 equals to 0. So we have here a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. Here a, b and c are the coefficients of the quadratic equation, and x is the variable that we are looking for, and we'll find out the value of x according to a special formula for x. The formula for x is x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a, and in our specific quadratic equation, our specific quadratic equation is t squared plus 2t plus minus 9 equals to 0. Here the missing variable is t, so x equals to t. T is the variable that we are looking for. The coefficient a equals to 1. The coefficient b equals to 2, and the coefficient c equals to minus 9. So we will put the data inside the equation for x, and we find out the value of t, because x equals to t. So x that equals to t equals to minus b. B is 2, so minus b is minus 2, plus minus square root of b squared. B is 2, so b squared is 2 squared, 2 squared is 4, minus 4 times a is 1, and c is minus 9, so it is minus 4 times minus 9, that is actually plus 36, divided by 2a, a is 1, so 2a is 2 times 1, that is 2. So t equals to minus 2 plus minus 4 plus 36 is 40, divided by 2. So t equals to minus 2 plus minus 40 is 4 times 10, and the square root of 4 is 2, so in conclusion we will get here that it is 2 times square root of 10 divided by 2. So here we will have two solutions that are possible for t, but first of all t equals to minus 2 over 2 is minus 1. So t equals to minus 1 plus minus 2 over 2 is 1, so it is plus minus square root of 10. I repeat again, we will have two solutions for t. The first solution is t equals to minus 1 plus square root of 10, and the second solution for t is t equals to minus 1 minus square root of 10, all divided by 2, of course. And we will focus on the second solution. T equals to x plus 1 over x according to our definition. So x plus 1 over x equals to x plus 1 over x equals to minus 1 minus square root of 10 and x is the length of one side of a right triangle, therefore x as a length is a positive number, therefore x plus 1 over x is also a positive number. So in this side of the equation we have a positive number, while in this side of the equation minus 1 minus square root of 10 is a negative number. And a positive number can never be equal to a negative number, so we have a contradiction. Therefore, this solution is incorrect solution. So we cancel that solution, and we left only with the solution that t equals to minus 1 plus square root of 10. T is x plus 1 over x, and it equals to minus 1 plus square root of 10. Here we will multiply x by x, and then we divide it by x in order to have a common factor with 1 over x. And we have here x squared plus 1 over x equals to minus equals to square root of 10 minus 1. Here we multiply this equation by x, and we get that x squared plus 1 equals to square root of 10 minus 1 times x. Here we subtract square root of 10 minus 1 times x from this equation, and we get a quadratic equation that x squared, that says that x squared minus square root of 10 minus 1 times x plus 1 equals to 0. We have here a quadratic expression and the coefficients of this quadratic equation are as follows: a equals to 1, b equals to minus square root of 10 minus 1, and c equals to 1. And the general solution for a quadratic equation, or the general formula for x is actually x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. So in our specific quadratic equation, we will put the data inside this equation for x, and we will find out the value of the values of x of our quadratic equation. So we get that in our specific quadratic equation, x equals to minus b, b is minus square root of 10 minus 1, so minus b will be equal to minus square root of 10 minus 1, that is to say it equals to square root of 10 minus 1 plus minus b squared, b is square root of 10 minus 1 square minus 4 times a times c. A is 1, c is 1, so minus 4 times a times c is minus 4, all divided by 2. So x equals to square root of 10 minus 1 plus minus square root of 10 minus 1 square equals to square root of 10 squared, that is 10, plus b squared, that is actually 1 squared, that is to say it is plus 1, minus 2 times square root of 10 times 1 minus 4, all divided by 2. So we got that x equals to square root of 10 minus 1 plus minus here 10 plus 1 is 11, 11 minus 4 is 7, so here we have 7 minus 2 times square root of 10, all divided by 2. So inside the root we have 7 minus 2 times square root of 10. We will present this expression in a different way. So actually 7 minus 2 times square root of 10 equals to 7 is 5 plus 2, minus 2 times square root of 10, square root of 10 is square root of 5 times square root of 2. So in conclusion, we found out that 7 minus 2 times square root of 10 equals to 5 plus 2 minus 2 times square root of 5 times square root of 2. Here 5 equals to square root of 5 square plus 2 equals to square root of 2 square minus 2 times square root of 5 times square root of 2. The expression square root of 5 square plus square root of 2 square minus 2 times square root of 5 times square root of 2 is very similar to the algebraic identity that states that a square plus b square minus 2 times ab equals to a minus b square. I repeat, this expression is very similar to the algebraic identity that a square plus b square minus 2 times ab equals to a minus b square. Therefore, according to this trigonometric identity, we can substitute our expression by a minus b square, and in our case a equals to square root of 5 and b equals to square root of 2. So we do it and we will get that square root of 5 plus, it is actually minus square root of 2 square. I'll repeat again, our expression square root of 5 square plus square root of 2 square minus 2 times square root of 5 times square root of 2 is very similar to the algebraic identity that a square plus b square minus 2 times ab equals to a minus b square. So actually we found out that the expression 7 minus 2 times square root of 10 equals to the expression square root of 5 square minus square root of 2 square. Actually it equals to square root of 5 minus square root of 2 square, because a equals to square root of 5, b equals to square root of 2, and a minus b square, it is actually equals to square root of 5 minus square root of 2 square. Therefore, we can substitute our expression that is inside the root, that is 7 minus 2 times square root of 10 by square root of 5 minus square root of 2 square. So we do it now and we will get that x equals to square root of 10 minus 1 plus minus and as I already told you, we said we substitute 7 minus 2 times square root of 10 by square root of 5 minus square root of 2 squared, because those two expressions are equal to each other. All divided by 2. So actually we found out that x equals to square root of 10 minus 1 plus minus square root of 5 minus square root of 2 squared, all divided by 2. And so x equals to square root of 10 minus 1 plus minus, here we have square and root, so the square cancels the root and we left only with square root of 5 minus square root of 2, all divided by 2. So here we have two solutions that are possible for x. The first solution for x, we define it as x1, and the second solution for x, we define it as x2. So the first solution for x will be x1 equals to square root of 10 minus 1 plus square root of 5 minus square root of 2 divided by 2. And the second solution for x will be x2 equals to square root of 10 minus 1 minus square root of 5 minus square root of 2 divided by 2. We'll continue with x1. So x1 equals to, here we have square root of 10, we will substitute square root of 10 by square root of 5 times square root of 2 minus 1 plus square root of 5 minus square root of 2 divided by 2. x1 equals, here we take square root of 5 as a common factor, and inside the root we will have here square root of 2 plus 1 here we take from those two expressions minus 1 as a common factor, and inside the squares, inside the brackets, we have the square root of 2 plus 1, all divided by 2. So x1 equals, here we take square root of 2 plus 1 as a common factor out of these expressions, and we get that inside the brackets we have here square root of 5 minus 1 all divided by 2. So in conclusion, we found out that x1 equals to square root of 2 plus 1 times square root of 5 minus 1 over 2. This is the first solution for x, and the second solution for x is x2. So we develop this expression, and again we substitute x10 and square root of 10 by square root of 5 times square root of 2, and we get that x2 equals to square root of 5 times square root of 2 minus 1 minus square root of 5 plus minus square root of 2 all divided by 2. Here we take square root of 5 as a common factor out of these expressions, and we get that x2 equals to square root of 5 as a common factor. Inside the brackets we will have here square root of 2 minus 1 and what is left here is here we have actually square root of 2 minus 1 all divided by 2. So x2 equals to, here we take square root of 2 minus 1 as a common factor out of those two expressions, and beside the root we will have square root of 5 plus 1 all divided by 2. So we found out the values of x1 and x2, and in the next step we will multiply x1 by x2, so first of all I will copy x1 and x2 in a new page, and we will multiply them by each other. So we have already found out that x1 equals to square root of 2 plus 1 times square root of 5 minus 1 all divided by 2. This is x1, and we have already found out that x2 equals to square root of 2 minus 1 times square root of 5 plus 1 divided by 2. Again, x2 equals to square root of 2 minus 1 times square root of 5 plus 1 over 2. Now we will multiply x1 by x2 and we will get that x1 times x2 will be equal to x1 is square root of 2 plus 1 times square root of 5 minus 1 over 2, and x2 is square root of 2 minus 1 times square root of 5 plus 1 over 2. So here I will organize the expressions in a different way, and we will get that x1 times x2 equals to square root of 2 plus 1 times square root of 2 minus 1 times square root of 5 plus 1 times square root of 5 times square root of 5 minus 1, all divided by 2 times 2. So here we will calculate the value of the expression square root of 2 plus 1 times square root of 2 minus 1 we will do it according to the algebraic identity that states that a plus b times a minus b equals to a squared minus b squared so square root of 2 plus 1 times square root of 2 minus 1 is very similar to a plus b times a minus b, and it must be equal to a squared minus b squared. In our specific expression, a equals to square root of 2 and b equals to 1. So this expression equals to a squared minus b squared. A squared is square root of 2 squared, that is to say it equals to 2, minus b squared. B squared, b is 1, so b squared is 1 squared. 1 squared is 1, so it is minus b squared, that is to say it is minus 1. So we found out that the expression square root of 2 plus 1 times square root of 2 minus 1 equals to 2 minus 1, that is actually 1. And then we have also to calculate the value of the expression square root of 5 plus 1 times square root of 5 minus 1 and if a equals to square root of 5, b equals to 1, and our expression equals to a squared minus b squared, that is to say a equals to square root of 5, so a squared is square root of 5 squared, and square root of 5 squared is 5, minus b squared. B equals to 1, so b squared is 1 squared, 1 squared is 1, so it is minus 1. So in conclusion, we found out that square root of 5 plus 1 times square root of 5 minus 1 equals to 5 minus 1. And in conclusion, we found out that actually x1 times x2 equals to 2 minus 1 times 5 minus 1 all divided by 2 times 2. So here 2 minus 1 is 1, 5 minus 1 is 4, all divided by 2 times 2, that is 4. Two times 4 is 4, and 4 over 4 is 1. So we actually found out that x1 times x2 equals to 1. So I'll repeat again. We found out that x1 times x2 equals to 1. What does it mean? It means that x1 is the inverse number of x2. And it means also that x2 is the inverse number of x1. Okay? But according to equation number 3, we already found out that x times y equals to 1. And if we put the solutions to the question inside the question number 3, the two solutions to the question, the first solution is x1, y1, and the second solution is x2, y2. So we will substitute x, we'll put the first solution in equation number 3, that is to say we will substitute x by x1 and we will substitute y by y1, and we will get that according to equation number 3, x1 times y1 equals to 1. So what does it mean? It means that y1 is the inverse number of x1. But we have already found out that x2 is the inverse number of x1. And according to the rule that every number has only one inverse number, it means that x1 has only one inverse number. So the two numbers x2 and y1 must be equal to each other in order that x1 will have only one inverse number, x2 must be equal to y1, or we'll conclude that y1 equals to x2. and we will put the second solution to the question, that is actually the question number 3 is x times y equals to 1, and the second solution to the question is x2 y2, so we put the second solution inside the question number 3, that is to say x will be equal to x2 and y will be equal to y2, and we will get that x2 times y2 equals to 1. What does this equation means? It means that y2 is the inverse number of x2. Okay, y2 is the inverse number of x2, but we have already found out that x1 is the inverse number of x2. x1 is the inverse number of x2. And according to the rule that each number has only one inverse number, it means that x2 has only one inverse number. And because of the fact that x2 has only one inverse number, it means that y2 must be equal to x1 y2 must be equal to x1 in order that x2 will have only one inverse number. y2 must be equal to x1. So we actually found out that y2 equals to x1, and we have already found out that y1 equals to x2. So the solution to the question is actually, we have two solutions to the question. The first solution to the question is x1 y1, and we've already found out that x1 equals to square root of 2 plus 1 times square root of 5 minus 1 all divided by 2 and y1, we have already found out that y1 equals to x2, therefore y1 actually equals to square root of 2 minus 1 times square root of 5 plus 1 all divided by 2. So this is the first solution to the question, and the second solution to the question is x2 y2, and x2 equals to square root of 2 minus 1 times square root of 5 plus 1 over 2. This is x2, and y2, we have already found out that y2 equals to x1, that is to say y2 equals to square root of 2 plus 1 times square root of 5 minus 1 all divided by 2. Okay, I'll repeat again. We have two solutions to the problem. The first solution to the problem is x1 y1. when x1 equals to square root of 2 plus 1 times square root of 5 minus 1 over 2, and y1 equals to square root of 2 minus 1 times square root of 5 plus 1 over 2. And the second solution to the question is x2, y2, when x2 equals to square root of 2 minus 1 times square root of 5 plus 1 over 2, and y2 equals to square root of 2 plus 1 times square root of 5 minus 1 over 2. Okay, that is the solution to the problem. Now I will summarize the lecture. Actually, we wanted to find out the values of line segments x and y. And we have a square, and inside the square we have the square is inside the right triangle ABC. We know that one side of the square is equal to 1 unit. So we also know that the hypotenuse AC of the right triangle ABC equals to 3 units. I repeat again, the square DEBF is inside the right triangle ABC. The hypotenuse AC of triangle ABC of the right triangle ABC equals to 3 units. And we want to find out the value of line segment FC that equals to x and line segment AD that equals to y. And we know that the opposite sides of a square are parallel to each other. That is to say, DE is parallel to BF. Here, DE is parallel to BF. And we know that BC is one side of the right triangle ABC. Therefore, it is absolutely a straight line. And we know that part of the straight line BC is parallel to DE. So if part of the straight line BC is parallel to DE, it means that BC itself will be also parallel to DE. So BC is also parallel to DE, and we have rule number 1 that corresponding angles between parallel lines are equal to each other. So here we have those two angles are defined as corresponding angles, and they are located between the parallel lines DE and BC. Therefore, they are equal to each other according to rule number 1. I repeat again. Angle AED equals to angle ECF according to rule number 1, because of the fact that those two corresponding angles are located between the parallel lines DE and BC. They are equal to each other. But if we define angle AED as theta, if angle AED equals to theta, then according to this equation, we get that angle ECF also equals to theta. So this angle ECF also equals to theta. So we found out that those two angles are equal to each other and they are both equal to theta. Then I presented to you rule number 2. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. Here, AB is one side of the right triangle ABC. Therefore, it is absolutely a straight line. So AB is a straight line. And if we focus on this side of the straight line AB at point D, then the sum of the angles at this point must be equal to 180 degrees. So if angle AD equals to x, then x plus 90 degrees must be equal to 180 degrees according to rule number 2. X plus 90 degrees must be equal to 180 degrees according to rule number 2. Here we subtracted x from this equation and we got that x equals to 180 degrees minus 90 degrees. That is to say x equals to 90 degrees. So this angle is right angle. Likewise, BC is one side of the right triangle ABC. Therefore, it is absolutely a straight line. So you can write here that BC is a straight line. So if we focus on the upper side of the straight line BC at point F, then the sum of the angles must be equal to 180 degrees. So if we define angle EFC as y, and this angle equals to 90 degrees, so angle y plus 90 degrees must be equal to 180 degrees according to rule number 2. I'll repeat again. 90 degrees plus y must be equal to 180 degrees according to rule number 2. We subtracted 90 degrees from this equation and found out that angle y equals to 180 degrees minus 90 degrees is 90 degrees. So angle y, this angle EFC equals to 90 degrees. Then we focus on the right triangle, triangle ADE. On this right triangle, tangents theta equals to AD over DE. I repeat again, in the right triangle, triangle AED, tangent theta equals to AD over DE. But AD equals to y according to our, what is given as the question. DE equals to y. So in conclusion, we found out that according to equation number 1, tangent theta equals to y. Then we focus on the right triangle, triangle EFC. In this right triangle, tangent theta equals to EF over FC. In the right triangle EFC, tangent theta equals to EF over FC, but EF equals to 1. FC equals to x. In conclusion, we found out that tangent theta according to equation number 2 equals to 1 over x. Then we created equation number 3 that states that tangent theta according to equation number 1 must be equal to tangent theta according to equation number 2. Tangent theta according to equation number 1 equals to 1, and it must be equal to tangent theta according to equation number 2 that equals to 1 over x. So in conclusion, we found out that according to equation number 3, y equals to 1 over x. Here we multiplied equation number 3 by x, and we got that x times y equals to 1. And whenever the multiplication of two numbers is equal to 1, what does it mean? It means that x is the opposite, is the inverse numbers of y, and y is the inverse number of x. And we also have the rule that every number has only one inverse number. The inverse number of 5 is 1 over 5 and only 1 over 5, and the inverse number of 1 over 5 is 5 and only 5. Okay? Then we focus on the right triangle, triangle ABC. On this right triangle, according to the Pythagoras theorem, AC square equals to AB square plus BC square. The square of the hypotenuse equals to the sum of the square of the perpendiculars. The square of the hypotenuse is AC square, and it equals to AB square plus BC square. AC equals to 3. AC square is 3 square. 3 square is 9. AB is y plus 1, so AB square is y plus 1 square. And BC is x plus 1, so BC square is x plus 1 square. In conclusion, we found out that according to equation number 4, 9 equals to y plus 1 square plus x plus 1 square. Here we open the brackets in this side of equation number 4, and we got that y plus 1 square equals to y square plus 2y plus 1 plus x plus 1 square is x square plus 2x plus 1. It equals to y, it equals to 9. But according to equation number 3, y equals to 1 over x. So we can substitute y by, y by 1 over x according to equation number 3. So we did it, and we got that y squared is equal to 1 over x squared plus 2y. 2y is 2 times 1 over x plus 1 plus x squared plus 2x plus 1 equals to 9. Here we organized the expressions in equation number 4 in a different way, and we got that x squared plus 1 over x squared plus 2x plus 2 over x equals to 9. Here inside the brackets, the expression inside the brackets that is x squared plus 1 over x squared plus 2 is equal to x plus 1 over x squared. And here we took 2 as a common factor from those two expressions, and inside the brackets we have x plus 1 over x that equals to 9. So here we took t as equals to, we define t that it will be equal to x plus 1, so t equals to x plus 1 over x, t equals to x plus 1 over x according to our definition. So here we can substitute in equation number 1 x plus 1 over x by t, we did it, and we got that this expression x plus 1 over x squared will be equal to t squared, and 2 times x plus 1 over x is 2t, minus 9 equals to 0. So here we have a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0, when a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for, and we will find out the value of x according to a special formula for x. The special formula for x is x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. But in our specific quadratic equation, that is actually t squared plus 2t minus 9, this is our specific quadratic equation. Here the variable that we are looking for is t, so x equals to t, the coefficient a equals to 1, the coefficient b equals to 2, and the coefficient c equals to minus 9. So all that is left to do here is to put the data inside the equation for x, and we'll find out the value of the values of t, because in our specific equation x equals to t. So we get here that t equals to minus b, b equals to 2, so minus b is minus 2, plus minus b squared, b is 2, so b squared is 2 squared, 2 squared is 4, minus 4 times a times c, it is actually minus 4 times minus 9, that is 36, over 2. So we got that t equals to minus 2, plus minus 4 plus 36 is 40, over 2, so t equals to minus 2 plus minus 40 is 4 times 10, the square root of 4 is 2, so it is actually, in conclusion, we found out that t equals to minus 2 plus minus 2 times square root of 10 over 2. Here we divided the equation by 2, and we got that t equals to minus 2 over 2 is minus 1, plus minus 2 over 2 is 1, so it is, in conclusion, we found out that t equals to minus 1 plus minus square root of 10. So here we have two solutions that are possible for t. The first solution is t equals to minus 1 plus square root of 10, and the second solution for t is t equals to minus 1 minus square root of 10. So we focus on this solution. The second solution for t, t equals to x plus 1 over x according to our definition. So we get that x plus 1 over x equals to minus 1 minus square root of 10. But x is the length of one side of the right triangle, so it must be a positive number, because length is a positive. And so in this side of the equation we have positive number, and in the other side we have minus 1 minus square root of 10, that is a negative number, and a positive number can never be equal to a negative number. Therefore we got here to a contradiction. Therefore this solution is incorrect solution, so we cancel this solution, and we left only with the solution that t equals to minus 1 plus square root of 10. Okay? So if t equals to minus 1 plus square root of 10, t, according to our definition, is x plus 1 over x, and it equals to minus 1 plus square root of 10. So here we multiply x by x, and then we divide it by x in order to have a common factor with 1 over x, and we get that x squared plus 1 over x equals to square root of 10 minus 1. Here we'll multiply this equation by x, and we get that x squared plus 1 equals to square root of 10 minus 1 times x. Here we subtracted minus square root of 10 minus 1 times x from this equation, and we got the quadratic equation that x squared minus square root of 10 minus 1 times x plus 1 equals to 0. So this is a quadratic equation, and the coefficients of this quadratic equation are as follows: a equals to 1, b equals to minus square root of 10 minus 1, and c equals to 1. And the solution of this quadratic equation is according to the general formula for the solution of a quadratic equation of x. We will get that the general solution is x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. And in our specific quadratic equation, x equals to minus b, b equals to minus square root of 10 minus 1, so minus minus is plus, and so minus b is equal to square root of 10 minus 1 plus minus b squared. B is minus square root of 10 minus 1, so b squared is minus square root of 10 minus 1 squared, minus 4 times ac is minus 4, all divided by 2. So we got that x equals to square root of 10 minus 1 plus minus, here square root of 10, square root of 2 times 10, square root of 10 minus 1 square is a squared plus b squared minus 2 times ab. A squared is square root of 10 squared, square root of 10 squared is 10, plus b squared, b is 1, so b squared is 1 squared, so it is plus 1, minus 2 times square root of 10 minus 4 over 2. So x equals to square root of 10 minus 1, plus minus, here 10 plus 1 is 11, 11 minus 4 is 7. So in conclusion, we found out that inside the brackets we have 7 minus 2 times square root of 10, and in conclusion we found out that x equals to square root of 10 minus 1 plus minus square root of 7 minus 2 times square root of 10 over 2. Then we presented the expression that inside the root in a different way. The expression inside the root is 7 minus 2 times square root of 10. 7 equals to 5 plus 2, and 2 times square root of 10. Square root of 10 is square root of 2 times square root of 5, so we substituted square root of 10 by square root of 5 times square root of 2, and we got this expression 5 plus 2, that 7 minus 2 times square root of 10 equals to 5 plus 2 minus 2 times square root of 5 times square root of 10. The square root of 5 is square root of 5 squared. Actually 5 equals to square root of 5 squared, and 2 equals to square root of 2 squared. So we substituted 5 by square root of 5 squared, and we substituted 2 by square root of 2 squared, minus 2 times square root of 5 times square root of 2. And here we have the algebraic identity that states that a squared plus b squared minus 2 times ab equals to a minus b squared. And a in our specific expression equals to square root of 5, and b equals to square root of 2. So a minus b squared will be equal to square root of 5 minus square root of 2 squared. So we substituted our expression by square root of 5 minus square root of 2 squared, because of the fact that according to this algebraic identity, those two expressions are equal to each other. Okay, and actually got that x equals to square root of 10 minus square root of 1 plus minus. Again, we substituted 7 minus 2 times square root of 10 that was inside the root by square root of 5 minus square root of 2 squared, because of the fact that they are equal to each other. And here we have square and root. The square cancels the root, and we left only with square root of 5 minus square root of 2. So in conclusion, we found out that x equals to square root of 10 minus 1 plus minus square root of 5 minus square root of 2 over 2. So here we will have two solutions for x. The first solution is x1 and the second solution is x2. The first solution, x1, equals to square root of 10 minus 1 plus square root of 5 minus square root of 2 over 2. And the second solution is x2 equals to square root of 10 minus 1 minus square root of 5 minus square root of 2 over 2. And here we substitute the square root of 10 by square root of 5 times square root of 2, and we got that x1 equals to square root of 5 times square root of 2 minus 1 plus square root of 5 minus square root of 2 over 2. Here we took square root of 5 as a common factor out of this expression, and we got that x squared equals to square root of 5, and inside the root we have square root of 2 plus 1 minus square root of 2 plus 1. So here we took square root of 2 plus 1 as a common factor out of this expression, and we got that x equals to square root of 2 plus 1 is a common factor, and inside the brackets we have square root of 5 minus 1 over 2. So in conclusion, we found out that x1 equals to square root of 2 plus 1 times square root of 5 minus 1 over 2. This is the first solution, and the second solution is x2 equals to square root of 10 minus 1 minus square root of 5 minus 2 over 2. Here we substitute the square root of 2 by square root of 5 times square root of 2, and we got that x2 equals to square root of 5 times square root of 2 minus 1 minus square root of 5 plus square root of 2 over 2. Here we took square root of 5 as a common factor out of this expression, and we got that x squared equals to square root of 5 is common factor. Inside the brackets we have square root of 2 minus 1 plus square root of 2 minus 1 over 2. Here we took square root of 2 minus 1 as a common factor out of this expression, and inside the brackets what is left is square root of 5 plus 1 over 2. So in conclusion, we found out that x2 equals to square root of 2 minus 1 times square root of 5 plus 1 over 2. So we found out the values of x1 and x2. In the next step, I copied x1 and x2 in this page, and we multiplied x1 by x2. So this is the multiplication of x1 by x2. Then I organized the expressions here in a different way, and we got that x1 times x2 equals to square root of 2 plus 1 times square root of 2 minus 1 times square root of 5 minus 1 times square root of 5 plus 1 times square root of 5 minus 1 over 2 times 2. So here we calculated the value of the expression square root of 2 plus 1 times square root of 2 minus 1 according to the algebraic identity that states that a plus b times a minus b equals to a squared minus b squared. And square root of 2 plus 1 times square root of 2 minus 1 is very similar to the expression of a plus b times a minus b, and this expression according to this algebraic identity equals to a squared minus b squared. Therefore, our specific expression will be also equals to a squared minus b squared according to this algebraic identity, when a equals to square root of 2 and b equals to 1. So this expression equals to a squared minus b squared. A squared is square root of 2 squared. Square root of 2 squared is 2 minus b squared. B is 1, so b squared is 1 squared. 1 squared is 1. So in conclusion, we found out that the value of this expression equals to 2 minus 1, that is actually 1. And then we calculated the value of the expression square root of 5 plus 1 times square root of 5 minus 1. According to the algebraic identity that a plus b times a minus b equals to a squared minus b squared. In our specific expression, a equals to square root of 5, so a squared is square root of 5 squared. Square root of 5 squared equals to 5 minus b squared. B equals to 1, so b squared is 1 squared. 1 squared is 1. So in conclusion, we found out that this expression equals to 5 minus 1, that is actually 4. So in conclusion, we found out that x1 times x2 equals to 2 minus 1 times 5 minus 1 over 2 times 2. 2 minus 1 is 1, 5 minus 1 is 4, and 2 times 2 is 2. Here 2 times 4 is 4, and 4 over 4 is 1. So in conclusion, we found out that x1 times x2 equals to 1. Okay, so x1 times x2 equals to 1. What does it mean? What is the meaning that x1 times x2 equals to 1? It means that x1 is the inverse number of x2 and x2 is the inverse number of x1. Okay, but according to equation number 3, we have already found out that x times y equals to 1. And here we have two solutions to the question. The first solution is x1, y1, and the second solution is x2, y2. So we will put the solution inside the question number 3 in order to find out the values of x1 and y1, x2 and y2. So here we put the solution, the first solution inside the question number 3. That is to say x equals to x1 and y equals to y1, and we got that x1 times y1 equals to 1. What does it mean that x1 times y1 equals to 1? It means that y1 is the inverse number of x1. But we have already found out that x2 is the inverse number of x1. Okay, so x1, we know that x1 has only one inverse number, according to the rule that every number has only one inverse number. That is to say, x1 has only one inverse number. So if we have two numbers, y1 and x2, that both of them are the inverse numbers of x1, it means that they must be equal to each other, because of the fact that every number has only one inverse number. x1 has only one inverse number, and if we have two numbers that are the inverse number of x1, they must be equal to each other. That is to say, y1 is equal to x2, and then we put the second solution inside the question number 3. The second solution is x2, y2. We put it inside equation number 3. That is to say, x equals to x2 and y equals to y2. So we got that x2 times y2 equals to 1. What is the meaning of equation number 3? The meaning of equation number 3 is that y2 is the inverse number of x2. But we have already found out that x1 is the inverse number of x2. Okay? But x2 can have only one inverse number. So if we have two numbers that they are the inverse number of x2, they must be equal to each other. That is to say, y2 is equal to x1, and we have already found out that y1 equals to x2. So the solution to the problem is that we have two solutions, x1 and y1, and x2 and y2. x1 is square root of 2 plus 1 times square root of 5 minus 1 over 2. And y1, we have already found out that y1 equals to x2. So here y1, that is actually also equals to x2, is equals to square root of 2 minus 1 times square root of 5 plus 1 over 2. And the second solution to the question is x2, y2. x2 equals to square root of 2 minus 1 times square root of 5 plus 1 over 2. And y2, we have already found out that y2 equals to x1. So y2 that equals to x1 equals to square root of 2 plus 1 times square root of 5 minus 1 over 2. So those are the two solutions to the question. Okay, thank you very much.